Hello everyone. So today we are going to discuss with the next topic, that's your deadlock. Okay. Before proceeding with actual definition, okay. So in a multi-programming environment, what happens is several processes will be requesting for the resources, and if the particular resources are not available at that time, if the resource are not available at that time, what happens? The process will go to waiting state. And sometimes what happens is, what are the particular process that goes to a waiting state may not be able to return to what again the execution state. Why? Because the resource whatever it has requested for, that is being held by some other waiting process. Some other waiting process. So let me give an example. Before that, what do you mean by resources? System resources. The system resources can be anything. It can be your memory, it can be your CPU, it can be your input device, it can be your output device, it can be your registers, whatever it may be. Right. In simple way, what I can say about the definition of your deadlock is two or more processes are waiting for some event to happen, but that event will never happen. Then what happens is that particular process will enter to what? Deadlock state. So assume I'll just give an example. Okay, some customer will go to bank and ask manager to create a bank account. And he'll ask, I want to create a bank account. So manager will say, so if you want to create a bank account, you need to deposit minimum of 5,000 rupees amount. But the customer will disagree and he'll say that first you create the account and then I'll deposit the amount. But your manager will refuse and will say that first you pay the amount, then we will create the account. So both will not agree at all. Okay, so here what happens is both the process of both customer and manager are waiting for what some event to happen. Customer is waiting for what? Creating an account before depositing. But manager is waiting for depositing the amount, then create the account. So both will not agree at all because of some rules or whatever it is. Then what happens is deadlock will occur. Or in other words, there is a one-way road. At a time only one vehicle can pass. And this vehicle is going in this direction and this vehicle is going in this direction. So whenever they meet each other, what happens is until and unless one vehicle should take reverse and give the way to what? The other vehicle. And normally this happens in India. If both don't agree, then what happens is here deadlock will occur. So that's what the definition you can see. Deadlock is a state of processes where the processes waits infinitely for what? For the resources that is being held by some other waiting process. So suppose I'll just say an example. P1 process is requesting resource R1. So P1 to R1, arrow mark. Okay. And resource R1 is being held by P2 process. Held means P2 process is holding this particular resources. And this P2 process is requesting for resource R2 and that R2 is being held by some other process P3 also. So here what happens is P1 process, it is requesting for what? Resource R1, but this resource R1 is being held by what? Some other waiting process. P2 is waiting for what? Resource R2. That is being held by what? P3 process. So then what happens is P1 will infinitely wait for what? The resource R1. That is being held by what? Some other process. So here what happens is deadlock will occur. So here they said that some system model, how exactly your system will look like for your deadlock situation, and they said that in your particular system there will be finite number of resources. Means it will be having some count, the number of resources whatever it is. And every particular resources can have some instances. What do you mean by instance is a thing, but assume that printer is one resources. If your system is connected with two printers, then what happens is you have how many instances of printer here? Two instances, that's it. But it can have what? Finite number of resources. And the particular process can request for what? Request for what? The number of resources whatever it is available. And the particular processes, multiple processes whatever it is there, it can share whatever the resources that are available in your system. And they said that the particular process or processes can request whatever the number of resources, okay, that is present in your system for execution. But the processor should not exceed the number of resources whatever it is there that is available in the system. Whenever it's going to request, it can request whatever the finite number of resources that are available, only within that particular resources it can request. And they said that there are some particular conditions, like when the resource can be utilized. There are three things, okay, namely request, use and release. So whenever a particular process want to use the resources, before using that it has to request for the resources. Once it has requested, it will be allocated. Then what happens is the process can use the resources for execution. Once it has completed the execution, then what happens is it can release the resources. And whenever process is going to request for the resources, and if the resource is not available, then it goes to what? Then it goes to your waiting state. Whenever the process is granted, it can use that particular thing. Whenever the process has finished the particular task, it can release the resources. Okay, hope you are getting. And they said that in your deadlock, some important topic is there. In order to occur your deadlock, there are some four necessary conditions. Okay, in order to deadlock to occur in your system, there are four necessary conditions. Okay, that are necessary conditions. Whenever deadlock will occur, it has to satisfy all these conditions. Four conditions are there. First one is mutual exclusion. Second one, hold and wait. Third one, no preemption. And fourth one is circular wait. These are the four necessary conditions that must hold good, okay, in order to occur what? Deadlock. If there is a deadlock in a system, all these four conditions has to be satisfied. These are four necessary conditions where the deadlock can occur. First one is your mutual exclusion. Okay, they said that at least one resource must be in non-shareable mode. At least one resource must be in which one here? Non-shareable mode. What do you mean by non-shareable mode is nothing but only one process at a time. Only one process at a time can use the resources. Only one process can use the resource at a particular moment of time. If any particular process is going to request the resources, that particular process must be delayed until what? Until the resource is being released. So they said that in a mutual exclusion, what happens is at least one resource must be in which mode here? Non-shareable mode. Non-shareable means it is not going to share the resource among what? Multiple processes simultaneously. So what do you mean by non-shareable mode is nothing but at a time, only one process at a time can use what? The resources. So whenever that is the case, if another process requests that resources, if another process is going to request the resources, the requesting process must be delayed until what? Until the previous process is going to release the resources. So whenever it is non-shareable resources, at that time what happens is your deadlock can occur in your system. So this is one condition where the deadlock can occur. Means all four conditions has to satisfy to occur what? Deadlock. The second one is what? Hold and wait. The name only indicates hold and wait. A process must be holding at least one resources. A process must be holding at least one particular resources and waiting to acquire additional resources. And waiting for what? Acquiring one additional resources. But that is being currently held by some other process. So suppose I said that P1 is holding at least one resources and it is waiting for what? It is waiting for one more additional resources, and that is being held by some other waiting process. Means P1 is already holding one resources and it is waiting for what? One more additional resources. But that is being held by what? Your P2 process. So whenever this is the case, whenever it hold one resource and request for one more additional resource, but that is being held by some other process, at that time also what happens is your deadlock will occur in your hold and wait. And the next one is no preemption. They said that resources whatever they are there are not preempted. No preemption or not preempted. Whenever it is not preempted, what happens? Normally deadlock will occur. Normally what happens is resource cannot be preempted. No preemption. Resource cannot be preempted. So whenever resource cannot be preempted, what happens is resources can be released voluntarily whenever the particular process is going to finish its task. Whenever it is going to complete the task, it has to voluntarily release the resources. So whenever there is no preemption of the resources, then what happens is deadlock will occur. So I'll give the example. See, P1 is holding resource R1 and it is waiting for what? Resource R2. But it is being held by what? P2 process. So P1 need what? R2. So if this particular process will preempt means, what happens? It can be allocated. But if there is no preemption until this finishes task and voluntarily release the resources, there will be no preemption. So whenever there is no preemption, what happens is deadlock will occur. Hope you are getting with that. And the last one is your circular wait. So simple thing. P1 process is waiting for the resources that is being held by what? P2 process. And P2 process is waiting for the resources that is being held by what? P3 process. And P3 process is waiting for the resources that is being held by what? Your P1 process. Whenever there is a circular path between the process, each process is waiting for the resource that is being held by some other process. At that time also what happens is deadlock will occur. So these are the four necessary conditions. If all these four conditions satisfies, then what you can say is the system is in deadlock state. So this is the basics about introduction to what? Your deadlocks. Thank you.